Hi all, and welcome to day 20 of the Advent of Elixir. In a previous video, which I'll link to below, I showed you how to make a transactional lock using Erlang's global module. In this video, I will show you how to use the other functionality of Erlang's global module, which is to be a global registry. One way to think about the global registry is that it's like Elixir's registry module, except it does a cluster-wide transactional lock and lets each node know what's been registered whenever a node change or whenever a change in the processes that it's registering occurs. Notably, the registry entries will be singletons by their global name. So to illustrate this purpose, we will use this to make a singleton node. Probably the most useful thing to use the global registry for, though certainly you can use it for other things. So what might you want to use a singleton for? Well, suppose you have a consumer of a third-party API, and you have a cluster where more than one units are accessing, more than one nodes could potentially be running in your cluster, but you only want one of them to connect to the third-party API. Perhaps that's for rate limiting purposes, or just generally because you only need one node to service requests, or you only want one node to service a request via some sort of active connection. So, for example, suppose we have a weather API and we don't want to, and the weather API doesn't support multiple connections coming in, so we only want one node in the cluster to be able to reach that weather API, third-party weather API. And the problem is that we don't know which node in the cluster is going to be up at any given time. Something may happen to one of them. You might do a rolling blue-green deploy or something like that. And so you want to be able to have a robust and always available a connection to that weather API via the node that is the singleton. Okay, so to demonstrate this, we're going to start with a basic module. And this module is just going to be a getter and setter. So let's take a look here. We've got this, it's a gen server, and it's got a get function, which we'll call by calling the name. For now, we'll just have that be the module. And then it'll go through this handle call, in which case we will just reply with the current state. And then for the set function, we're just going to send the set new state message, and then we're going to reply with OK. So let's take a look at and see what that looks like with just one node. So now, because we've done a local registry of this using the Erlang's local name registry, we've set the name of this to be module, so we don't have to pass that PID anywhere. We can refer to it with this atom. So, so we can do advent.get, it should be nil. We can set it to foo, and then advent.get will also be foo. Okay, so the problem with this is that if I build a second module and start a second virtual machine and connect it, so this will auto connect. You can see it's connected to the left side. If I do advent.get, well, first of all, we haven't started the local server, so let's go ahead and do that. Okay, and if I do advent.get, it's still nil, and it doesn't know about this other one. So if I do advent.set to bar, and then try and get this side, it's still foo. So they aren't talking to each other. Well, the advent modules aren't talking to each other, despite the fact that these two nodes are networked. The first thing I want to solve is I want to make sure that these modules are started automatically in the application tree. So what I'm going to do here is I'm going to go to the application module, and I'm going to change the children to have advent instead of just nothing. This will auto launch the advent gen server when we start the application. It's unsupervised, but for the purposes of this demonstration, that should be fine. So let's go ahead and start both of these up again. However, the state of them being disconnected hasn't changed. We haven't really substantially changed how they talk to each other. So node.list on both sides shows the other side. If I do advent.set and then advent.get, it's still nil. Advent.set on this side, and this side also the same. So they're not talking to each other in any useful fashion. So the next thing I'm going to do is let's go and make this actually clustered so that the two of these can talk to each other. So now I'm going to uncomment this, and then I'm going to now make this a global module. And the way to do that is to pass it to the global registry. The way we do that is by making a tuple that starts with the module that is the registry, and the name parameter in the gen servers can deal with that as we expect. So let's go ahead and kill both of these. However, note that because I've changed the application.ex, in this case it won't auto start. So now I'm going to auto start it manually on the left hand side. Okay, so now this is started, and if I do advent.set to foo, and then on this side do an advent.get, I'll see that the value matches the side on the right hand side. Advent.get foo. And similarly I can do advent.set bar, and then advent.get, and now it should say bar. Okay, so how did that work? Just as when we are on a single node, the name parameter could forward it to any local process that's been registered to that atom. With the global module, what we can do is we can just register it to the global registry, and any node that's connected in our system can be able to access the location just by passing that via parameter to this name here, or to the first parameter of genserver.call or genserver.cast or anything like that. Okay, so this is now a global system. The problem is, what happens when I attempt to launch it automatically? You're going to see that we had a problem. Application advent exited shutdown, and there was a global name conflict terminating advent PID 19199.159.0. Okay, so here, this odd node on the left was the one that had a running advent module, and then I got a message saying that somewhere else we had a PID 19199.150 that tried to register with the global registry, and there was a name conflict. So, however, I do have a running version of Advent of the Advent gen server, so I can set this, and that will work. And on the right-hand side, advent.get will work. The other thing that you should notice is that application advent exited shutdown. What this means is that the Advent application itself wound up getting killed somehow. Something here went wrong. and it failed to start the supervisor. And if I had any other parts of my application that were in this Advent application supervisor tree, it would be gone. The reason why we still have a prompt is because there's other applications running in this Beam virtual machine, like IEX and Mix. And so those, so IEX will respect the fact that they're still running and will not necessarily shut down if your main application gets killed. If you do a release, however, that will be fatal, and it will stop the application. And in particular, what you'll notice is that if I terminate this virtual machine on the left, which is hosting the Advent gen server, now I try to do advent.get, and I'm going to have a process not alive because it was expecting to see it over there. Okay, so we have a number of things that we have to fix in order to get this to work. Well, the first thing I want to do is I want to not crash the right-hand side when it tries to start a globally registered content. And the way I'm going to do this is we're going to go ahead and inspect the result of genserver.start link right here. So I'm going to stop both of these virtual machines, and I'm going to start the left one first. We'll let that spin up and get its Advent server registered. And on the right-hand side, I'm going to run it, and then we're going to see what the response was. So here we had OK PID 172.0, and here we have error already started, and that one gets triggered multiple times. This winds up looping a few times because the supervisor tries to start Advent, it gets an error, so it tries again, and eventually, after so many attempts, the supervisor will say, I've tried too many times, I give up. Okay. So what we're going to do is we're just going to case this, and we're going to specifically trap error already started, and we don't care what the other PID was, and then we're just going to make that ignore. We still need to trap the OK cases, and then the error cases. You could also potentially make this a catch-all and try and get anything out of that with some sort of any matching. So let's see what happens when we do this, when we reload this code. Okay, so this one presumably loaded the Advent correctly, and this one will presumably not load it correctly. So note that we had this name conflict terminating message, but we didn't have the our application died message. Of course, if we do advent.set foo and then advent.get on this side, it works. And so in the same way, we're still talking to the Advent on this side, and then if I kill it and I attempt to do advent.set, we're going to get can't find it. So let's solve this problem next. Okay, so what we have to do is we have to listen for when the other node goes down, and when the other node goes down, we're going to start up our own Advent process. So how are we going to do this? Well, the way we're going to do it is we're going to create a supervisor that contains something that watches for the node to go down, and then also the module that is the singleton. And the way this is architected, if you had other modules that were that were gen servers or whatever that you wanted to also be singletons, you would put them after all of these, and they would all be grouped together. So let's go through the logic of this. This singleton supervisor is a supervisor that's designed to manage multiple singletons. Truth be told, if you were doing this in a real deployment, you would probably want to pass the singleton supervisor a list of all of the modules that you would want to supervise, and then you would launch a children that was the singleton watcher, which I'm going to show you in a moment, followed by all of the modules that actually are singletons. So let's look at the Advent singleton watcher. And this code is incomplete, and we're going to go through filling this out ourselves. So what we want to do is we want to monitor when nodes are coming up, and or specifically when nodes are coming down. Because when one node comes down, it may or may not have had the Advent process running in it. And so we just want to competitively attempt to obtain to start an Advent monitor if necessary. Okay, so let's take a look at this. So we're going to go ahead and run this, and the way we're going to do this is we're going to put advent.singleton supervisor inside of the application here. So note that our tree is going to look like our application. Our application supervises the singleton supervisor, and then our singleton supervisor itself supervises the advent, as well as the singleton watcher. Note that here the strategy is one for all, and that's going to come important later. But for now, let's just run this. Okay. Okay, so the first thing we got was that we got this node up message, and we also got a node down message, and both of these were unexpected messages in handle info. Note that this node up message has a structure left at pop.os, and on this side is right at pop.os, so what it's telling us is node up, the node name right at pop.os came up and we saw it, and vice versa. This guy's the right-hand side saw the left-hand side, and then when I Control-C the left-hand side, the right-hand side got notified with node down. So we need to trap these messages. Our handle info hasn't been implemented, so let's go ahead and implement that. I'm going to not care about the node down or node up case because we don't care that much about this. We just care about node downs. So node down, and we also don't really care which node came down. So what I'm going to do is I'm going to write one function header here, and then I'm going to write a second one that's just going to be blank, and that's going to be any other node messages that we don't care about, since we subscribe to many different types of messages via this monitor nodes. Okay. Well, for handle infos, we want to do no reply, and then we're going to pass continue to state, which doesn't really matter because it's just an empty list state. But when the node down happens, somehow we want to trigger the entire system to restart the advent module. So how do we do that? Well, all we have to do is stop, we give a reason, normal, and state. How does this work? How does just implementing the stop normal wind up causing Advent to be restarted? Well, what happens is when we get the node down message, we stop the singleton watcher. When the singleton watcher stops, the one for all strategy triggers, which means that every other one of the children will also be stopped. And once this other child stops, then it also gets restarted by the supervisor, and then when it restarts, it will attempt to do this to register itself with the global registry. And of course, if it doesn't matter, then if it's already been started, then it gets ignored. The interesting thing about this is that we can get a really cool race condition that actually works to our favor. So suppose we had more than one other node. Say we had 5 nodes, and all of them detect the node down message that gets sent that they subscribe to because they're monitoring the nodes. And the node that happens to have Advent is the one that just fell over. Well, the other 4 nodes will attempt to launch an Advent server, and it's going to be okay because only one of them will win because it's a global transaction lock on that process. And then the other 4 will fail, they'll just get ignored, but we'll still only have a singleton advent running on whichever node happened to be the first, and we kind of don't care. Conversely, if a node that isn't one that is hosting isn't the node that is currently hosting the advent server dies, all of them will still get the node down message, and then all of them will restart, attempting to be the first to launch an advent module. Yes, there will be a short period of time where we'll lose service because the advent module has been killed and a new one has to start in its place. But ideally, the way that you've architected your Elixir system is that if anything unexpected happens, you'll get a crash. If a genserver.call happens, you'll get a crash, and everything else will be handled at least in a sane way via your application supervisor tree. This is why it's important to not try and catch exits from genserver.calls all that often, because you may not know why the other processes died, and you can't really guarantee that you have an understanding of what's going on that's sophisticated enough for you to warrant handling that error. Okay, so now that we've done this, let's take a look and see what happens. So I'm going to load this one first. And then I'm going to load this one. Now, the one on the left here is the one that holds the advent service. So advent.set. Okay. Now advent.get. And if I kill this one, I still can do advent.get without a crash, although it won't know what the contents were because it's a new process. So basically that's what I have to say. It's important to note that you have to be very careful with stateful singletons, because you'll need some way to communicate those important state changes between the nodes when the nodes have to resurrect their singletons. So that might be talking to a database, and make sure that initialization and retrieval of the bootstrapping data occurs in your gen server's init phase is typically what you want to do. However, for purely stateless systems like those that access APIs, this is really fantastically easy. For more complicated situations, you may also want to consider using a library like Swarm or Horde, which use some sort of distributed knowledge system like CRDTs to keep track of the state of whichever modules you care to keep track of. Okay, so that is it. That is a description of how to use global to create a singleton process in your cluster. Hope that was helpful, and I will see you tomorrow. Take care.